Welcome back. Today we're going to talk about configuring database connectivity, how we manage in AzStudio our database connections and our OData layer, and the tools that wrap this. Since this is such a large topic and goes very deep into our API and API usage, we're going to break this up into several videos. Don't worry though, once we finish databases, we're ready to start coding. The first thing to get out of the way is that our team is a bunch of older programmers, people who have been around the block more than once. And we've decided or come to the conclusion after using many different frameworks that the best, most consistent framework to use for accessing data in a PaaS environment is not code first. Instead, it's OData layers connected to store procedure layers, and then using LINQ to normalize that information. Why did we choose this? Well, we chose this because all of the other APIs that we see exposed in the Azure PaaS environment are also using this model. They're using an abstraction to an API and then wrapping that with a LINQ layer. So we decided to make our SQL access consistent with those other APIs. Now, some of you Entity Framework or Hibernate fans are gasping in horror right now. But don't worry, you're not required to use this data layer. It's just the layers that our APIs use to communicate to the different configuration databases and assets that you might want to point things to. If you want to use Entity Framework and Hibernate, feel free to do so. Some of the automation and code templates aren't going to work correctly for you, and you'll have to come up with your own workarounds. But that's actually a very minor inconvenience, and probably something you won't even encounter in your day-to-day programming. You can still use your Hibernate or Entity Framework or other SQL data access layers in your same manner. Our APIs will actually allow you to configure them through this set of screens. You'll just have a slightly different hookup methodology at runtime. And just to reinforce this point, you don't have to use this database layer, but pieces of this database layer will guide you in using your framework of choice. We don't force you into a data access pigeonhole because we don't think that's the right thing to do to programmers. Alright, so let's start with environments. When we were first building this workbench, basically the workbench evolved out of a lot of work we were doing, a lot of projects we were doing in the early Azure environments. So environments at first were treated as database environments, but later became expanded in their meaning, and now they mean what environment your app is actually operating in. So that's how this tool ended up in the database group, even though it represents a lot more than just the database environment you want to connect to. So when you describe an environment in this table, you're actually describing both the database environment you wish to connect to, an instance, but also you're describing what's in this button as well. So environment is environment. It just happens to be in the database group because that's where it ended up in the beginning. You can enter as many environments as you like in this system and map them to any resources you like. It's even possible to prefix or suffix these environment names so that you can actually manage all of your application environments for all of your offerings across the entire PaaS fabric. For instance, you could have app 1 dev, app 2 dev, app 3 dev. And they'd all be consistent and they'd be configured separately based on which one you've entered in the other configuration dialogues. So essentially, there's no limit to the number of environments and the number of applications that you can set up in the environments dialog. It just depends on how you want to manage things and how you want to break things out from a security perspective. The next concept to think about is the shard concept. Shards mean exactly what they do in database programming or database architecture, in that you can take a logical database schema and split it into multiple physical database hosts so that you can manage load across one image. And database shards can be configured to as many as you like, and they can be configured to point to as many physical instances as you like in our system. As a default, we use main as our main shard, and all of the AzStudio base schema gets deployed there. That doesn't stop you from breaking it up and changing which shard things map to, but as a basic default, we feel that the Azure fabric is scalable enough to have one shard. Federation segments is our next topic, and basically we come out of the box with a couple of federation strategies that the stored procedure layer is capable of using. This is above and beyond the federation technology that's already available in Azure and the Azure fabric. So you'd have to basically scale beyond what the Azure fabric could comfortably give you before you would need to pick a strategy here. These things are slower, and they do require multiple queries across different instances where the Azure fabric can kind of hide that from you. For 99% of our customers, the single instance is the only instance you're going to use. All right, next up is the concept of physical databases. This is where we actually put the connection strings in for the database instances or database servers and databases that you want to connect to. You basically map each connection to an environment name, a shard name, a federation segment, and give it a connection label. This data is, of course, encrypted at rest in the configuration database. Now, each of these database connections can be tested ahead of time. For instance, I can test this. I can test all of the connections at once. So I'm guaranteed that these connection labels will work when they're referenced at runtime. Now you may notice that there isn't a shortcut name here. There's a connection label, there's an environment name, and there's a shard name. The runtime APIs actually ask for a connection to shard name, which acts as the shortcut based on the environment name and the connection string and the federation segment that's currently in use. There is no shortcut to a database per se. There is the request to connect to a shard instead. So consider your shard name to be your shortcut in these cases. Also, when we talk about configuration providers and the configuration services, we'll explain a little bit more in depth about how databases, especially the primary connection database and the config connection database, are described not in the database itself, but in the actual configuration schema, which is a little different. Next up are client services. Client services can be thought of as business objects plus client services that are trying to connect to your resources. A client service name must be provided when a lookup is being done to connect to a database shard. We'll show you more about this in the code itself. But for now, just keep in mind there's only one default business object, the AzStudio business objects. And that business object must be given permission to access your shards, or API calls will fail. You can create as many client services as you like. You grant the client services rights to different shards here in the client service rights table. AzStudio business objects, as you can see, has the ability to access these connections in these environments. For a programmer to connect and execute against a particular database instance, they will have to know the client service name or business object name that you've assigned to them, and the shard name that they'd like to connect to. So for most information, AzStudio Business Objects uses the main shard in order to connect and read data. You can also test these configurations by simply selecting a row and pressing test and making sure that the business object can actually connect to the correct database instance. This means that individual coders must be given a valid business object name, and that business object name must be mapped to the proper connection label, and that connection label must be mounted or mapped to the correct shard for that business object to actually access data in the target database. 99% of the time this is business object connection label, and the connection label is mapped to main. If you have a sharded database, this becomes a little bit more complex on the back end. This mapping system allows you to issue business object names and then map them to particular database connections with different authentication information in those connections. You can issue connection information or connection labels to the main shard name to different business objects. That way, the business object, when it tries to connect to the database, would be in a more restrictive domain on the database server itself, and not able to access critical or sensitive information. What's nice is that you can test all of this ahead of time and make sure that it's working properly before you give any information to the programmer or commit any information to your system. And of course, AzStudio has a nice set of tools to help you test that. SQL Execute allows you to run SQL against different physical database instances. So if you have different database instances with different permission levels, you can test the access to that different database connection definition all at once. So you can just basically write anything you want in the SQL, select whatever you like here, and run it and watch for errors. In many cases, you're looking to generate errors where you're trying to access tables or schema that isn't allowed by that particular connection. And once you're comfortable that that's all locked down from the API point of view, you can then issue the programmer the shard name and the business object name that they can actually access. For purposes of this sandbox, we're just going to continue to use the AzStudio business object and the main shard. We don't want to overcomplicate our data access while you're learning the system. Thanks for watching.